For today's quiz, we have 3 resistors versus 1. It looks something like this. And you'll notice over here that we have a 100 ohm resistor, 15 volt battery supply. On this other configuration, we have 1,000, 100, and 1,000, same battery supply. Our question is, which of these two configurations will allow more current to flow? Same battery, 1 resistor, 3 resistors in that configuration. As always, please mark your confidence level and your explanation. Let's tackle this conceptually. We don't even have to use the numbers. Our configuration here, I have a 100 ohm resistor. I'll just call that R. And notice it's the same resistor over here. These other two are 1,000. They're bigger. That's all I need to know. We want to simply know which one of these is going to allow more current to flow. The easiest way to think of this conceptually is think about trying to go into a stadium or a show. People will walk unimpeded along the sidewalks. We can call those wires. But when you get to the ticket counter, or the person that takes your ticket, or the machine that you have to scan, that's where the bottleneck is going to happen, always. And so you'll end up slowing the crowd down to get through this particular resistance in getting into the stadium. Well, I also have that here. And in fact, if I ignore this big resistor and that big resistor, and I just drew them to scale like they're much bigger, if I didn't have these, well, I would still have that one ticket counter. And what we all know is when another ticket counter and another ticket counter suddenly open up, more people can get to the other side and get into the stadium quicker. So this is, of course, going to allow more current to flow. And here's why. Remember, this ticket counter is independent. It's the same thing as over here. These two don't care if another ticket counter is open. They're still going to allow a certain amount of, certain number of people to go through. If another ticket counter opens next to them, and maybe this is your star ticket counter, maybe this person isn't going to allow as many people through, but they're still allowing some people through. So whatever this counter is doing is now going to be helped by that ticket counter, even if they're not as good, and same thing here. So we would expect much more current to flow through this circuit than this circuit. It's an easy way to think of it. That's your quiz for today. And now let's talk about some common student ideas. The first thing that a student is going to see is they're going to see, I have more resistors here, and therefore they're going to think, I've got more total resistance. That's not normally the case in a parallel circuit. It's never the case, especially when the R's are equal here, this R and that R. In this case, they're going to end up looking and saying, well, look, I've got big resistance here, and I've also got some resistance here. And they're going to be thrown off by that. So that's why conceptual analogies are really useful for helping students understand parallel circuits. All right, that's your explanation for today.